Hi, in this video I'm going to show you how to find the square root of a complex number. So it says find the square root of 5 plus 12i. So if you let the square root of 5 plus 12i be a plus bi, and the thing is that a and b are real numbers, which is the sort of general form of a complex number, then we want a plus bi is equal to the square root of 5 plus 12i. If we square both sides, then we get a plus bi squared is equal to 5 plus 12i. And then if we expand the left-hand side, we get a plus bi times a plus bi. And then a times a plus bi times a plus bi. So we're just expanding this here, this bracket. So that's going to give me a squared plus abi plus another abi plus b squared I squared. That's still equal to 5 plus 12i. So it gives me a squared plus two lots, because we've got two lots of abi plus b squared. Now I squared is equal to minus 1. So I squared is minus 1. So this be minus b squared. So that now becomes a minus b squared plus 2abi must be equal to 5 plus 12i. And now what we do is we equating the real and the imaginary part. So the real part, a squared plus b squared, because no I there, will be equal to 5. And then the imaginary part, 2ab, will be equal to 12. So we make two equations. A squared plus b squared is equal to 5. And 2ab is equal to 12. And this idea of equating the real bit and the imaginary bit is quite useful when we're doing with complex numbers. Right, from this one, we'll label that 1 and 2. So from 2, we can say that b is 6 over a, because if we make b the subject, we're dividing by 2b, so 2 goes into 12 six times, so it'll be 6 over a. And now substitute into 1. So we're going to have a squared minus b squared, so it's going to be 6 over a all squared is equal to 5. Carrying on. So squaring now, so we've got a squared is 36 over a squared, so squaring the 6 and the a is equal to 5. Multiplying by a squared, the whole thing, we're going to get a to the 4th. When we multiply this one by a squared, the a squares will disappear, so we get minus 36 is equal to 5a squared. Right, so then we will write this, put this equal to 0. So we've got a squared minus 5a squared minus 36 is equal to 0. Now this is what's known as a disguised quadratic, i.e. if we just make a squared something else, we'll just get a quadratic equation. So we can factorise this. We've got a squared and a squared. So we want two numbers which multiply together make 36. We get minus 5. So try minus 9 and plus 4. And then either this bracket is equal to 0 or that bracket is equal to 0. So either a squared is equal to 9, which gives that or a squared is equal to minus 4. Now, this is not possible because when you take the square root of minus 4, you're going to get an imaginary number, and a, to begin with, was a real number. So this is not possible. So therefore, we're going to just get two solutions from here that, taking the square root of 9, that a could be plus or minus 3. Substitute into b is equal to 6 over a, and it's going to give that b is plus or minus 2, because we put 3 in there, we divided by into 6 we get 2, and then obviously put minus 3 in there, we're going to get minus 2. So the square root of 5 plus 12i will be plus or minus 3 plus 2i, or we can write it out as minus 3 minus 2i, or 3 plus 2i. Okay, so this has been a video to show you how to take the square root of a complex number. I hope you've understood, and I thank you very much for watching.